This video is for class 9 physics, and today we shall do upthrust in fluids from the chapter Upthrust in Fluids, Archimedes Principle and Flotation. Okay, so let us start the chapter. So coming to the first section of the chapter, which is upthrust, right? The other name for upthrust is buoyant force, right? And we have to understand what buoyancy is. When an object or a body is partially or wholly immersed in a liquid, an upward force acts on it. This upward force is known as upthrust or buoyant force. It is denoted by the symbol FB. Thus, the upward force exerted on a body by the fluid in which it is submerged is called upthrust or buoyant force. So the object is feeling a force because of the fluid, and that force is known as upthrust or buoyant force. Now let us understand what buoyancy is. The property of liquid to exert an upward force, okay, the property of the liquid to exert an upward force on a body immersed in it is called buoyancy. This property can be demonstrated by the following experiments. Okay, before going to these experiments, I would like to play one small clip, okay, regarding this upthrust. As you can see, I have taken one container, right, which contains water, fluid. Let me change the color. Okay, it contains water, and I've taken a ball, right? When the ball is released, obviously the ball will fall down. It will fall because of its weight, right? Here you can see the surface of water, right? So let's see what happens when the ball is released. So what happened when the ball was released? As you can see, when the ball was released, the ball went down because of its weight, right? But the water is resisting the ball, okay, resisting the ball such that the ball does not go in, right? So this property of the liquid or the fluid to resist the ball from coming down or to apply one upward force, okay, upward force, right? It is applying one upward force. So to resist the ball from coming down, it is applying some upward force. This upward force is known as upthrust. This upward force is known as upthrust, right? I hope you have understood till here. Now further understanding this, so as you can see, the some portion of the ball is submerged here. The some portion of the ball is submerged here, right? Now as the ball is being tried to push more and more force is being applied by the fluid. More and more force being applied by the fluid. So to keep the ball under the water, some force needs to be applied, right? To keep the ball under the water, some force needs to be applied. Okay, so from this video, okay, I think you have understood few things. Okay, let us discuss them in detail. Let us try to relate the same experiment, okay, the experiment number 1, which is given in your book, with the video clip which you have seen just now. So take an empty can, we have taken a ball. So instead of empty can, we have taken a ball. Okay, so then close its mouth with a airtight stopper and put it in the tub filled with water. It floats with a larger portion of it above the surface of water, and only a small portion of it is below the surface of water, as you have seen in the video. So if we push the can into the water, the ball was pushed into the water, we feel an upward force. which opposes the push, right? As you can see, the hand was trying to push the ball down. The hand was feeling some force. The ball first slipped also, which opposes the push, and we find it difficult to push the can further into the water. She was finding the she was finding difficult to put the ball in the put the ball in the water. So it is also noticed that as the can is pushed more and more into the water, as the ball was pushed more and more into the water, more and more force is needed to push the can or the ball further into the water till it completely immersed. So when the can is fully inside the water, when the ball was fully inside the water, a constant force is still needed to keep it stationary at that position. Now, if the can is released or the ball was released at this position, it is noticed that the can bounces back to the surface and starts floating again, right? So I hope you have understood this. I hope you have understood this. So going to the next experiment, which is pushing a cork into water. If a piece of cork is placed on the surface of water in the tub, it floats with nearly 2/5 of its volume inside water. If the cork is pushed into water and then released, it again comes to the surface of water and floats. If the cork is kept immersed, our fingers experiences some upward force. The behavior of the cork is similar to that of the empty can or the ball. Okay, so I hope you can relate the videos with these particular experiments. So now going to the explanation part. So when the can or the cork or the ball is put in the tub of water, two forces acts on it, right? Its weight, that is the force due to gravity W, which pulls it downwards, and the upthrust FB due to water, which pushes the can or the cork or the ball upwards. It floats in the position when the two forces become equal in the magnitude, that is W equals to FB. Now as the can or the cork is pushed more and more inside the water, the upthrust FB exerted by water on it increases and becomes maximum, that is FB dash, when it is completely immersed in water. So when it is released, the upthrust FB dash exerted by water on it being greater than its weight or force due to gravity, it rises up. To keep the can or the cork immersed, an external force, that is FB dash minus W, is needed to balance the net force. That means we need to keep on applying the force to keep it at the bottom or fully immersed. Okay, so let us try to understand this also with the same clip. Okay, I'm going to play it again. Now coming to this condition here, okay, the weight of the ball is acting vertically downwards, let it be W, right? And there is another force which is acting vertically upwards to balance the weight of the ball given by the fluid, that is water here, is upthrust, which is denoted by FB. So under this condition we can write FB, that is the upthrust, is equal to the weight of the object. The upthrust is equal to weight of the object. I hope you have understood till here, right? So now at this condition we can say the object is floating. So it floats in a position when the two forces become equal, that is W equals to FB or FB equals to W. Now as the can or the cork is pushed more and more inside water, or the ball is pushed more and more inside the water, so let us try to understand that line also. So now I have again played the video. Now as the ball is being pushed more and more, right, below the surface of water, the value of the upthrust increases. The value of the upthrust increases, right? So under this condition, my FB is still there, right? but this time the value of FB is more than the previous value because the submerged portion is more, so this much portion is submerged, and you can see some force is being applied to keep the ball under the water, right, to keep the ball under the water. Now further continuing with this video, as you can see, when the ball is fully submerged under the water, under this condition, okay, now my upthrust, upthrust or the buoyant force is equal to FB dash. This is only true when the object is fully immersed under the water. It is only true when the object is fully immersed under the water. So FB dash, that this is the maximum upthrust which a body can experience, okay, is always greater than the upthrust. So this is the maximum upthrust. So FB dash, which is the maximum upthrust when the body is fully immersed under the water, is always greater than the upthrust when it is partially immersed under water. So here what you can understand is, as the body is more and more being immersed under the water, the upthrust also increases. Now under this condition, as this FB dash is bigger than this FB, the previous value when the ball was on the surface of water, now if I release this, okay, suppose we release this ball right now, so what will happen is it will come up, right? Why will it come up? The reason is because here the value of FB dash is much more greater than the weight of the ball, right? Right? Now I hope you have understood till here, okay? When the ball was kept underwater, an extra bit of force was applied, here. Now what will be the value of this force? The value of this force will be FB dash, the upthrust, the maximum upthrust when the body is totally immersed underwater, right, minus the weight of the object. So this much amount of extra force needs to be applied, okay, on the object to keep it under the surface of water. I hope you have understood till here, right? So going to your book, so coming back to the book, note, like liquids, gases also have the property of buoyancy, that is they also give upthrust, that is a body immersed or placed in a gas also experiences an upthrust. All objects including ourselves are also acted upon by a buoyant force due to air, but we do not feel it because it is negligibly small as compared to our own weight. On the other hand, a balloon filled with hydrogen or any gas less dense than air rises up because the upthrust or the buoyant force on the balloon due to the surrounding air is more than the weight of the balloon filled with the gas. So that means this paragraph also wants to say that fluids, that means liquids or gases, right? Liquids and gases, both of them can give upthrust, right, when an object is immersed in them. So I hope you have understood till here, right? So this much for this video. Thank you so much.